So in a previous video, we had looked at, just generating a very simple line plot using matplotlib. In particular, we just generated some integer values for x ranging from -20 to +20. And then we created essentially a list of y values, which were the squares of all of those x values. And then we use plt subplots and then ax.plot to plot those. And we get the figure that's shown here. All right, so we've got a parabola centered at 0 and just a basic plot. Now what I wanted to do in this video was just to show you a little bit about customizing some of these subplots. So just again to kind of show you a few of the options and really maybe to give you some insight into how to utilize matplotlib's documentation, because like something like a pandas, matplotlib is a very large library. There's a lot of things that it does and is capable of doing. And sometimes the documentation, because of that, can be a little bit challenging to navigate. So let's just look at a few examples of doing that. All right, so first off, we've got our very basic line plot of our parabola centered at 0 right here. There's a few things that if I were to take a look at this and just say, these are things that I might want to improve about this plot. Quite a few things, actually. So first off, this top and right side, those dark black lines, essentially those borders, those are really not providing any information. They're just a border on around the figure, right, or around that plotted region. So those things are non-informative. So personally, I like to remove those. Those are kind of some visual clutter right there. They're not providing any information. And again, there's books out there on making compelling visualizations for data storytelling and those type of things. And this is a suggestion that I see a lot, is just removing any sources of visual clutter. So I might want to take away that top and right side of that border region. Also, currently we don't have any labels on our horizontal and vertical axes. We might want to add those, and then maybe we want to give it a title. And right now it's a little bit big, so I can't really see the figure region and my code all together. So maybe I'd do a little bit of resizing on that just to make it where it can kind of fit together. All right, so let's look at all of those various things. So let's first start with the sizing aspect of it. And the place that is controlled is in that subplots call. So if I go up here to plt.subplots and hold down shift and hit tab, right, we see we get a lot of arguments here. Now we've got number of rows, number of columns. Right now we just want this one subplot region. But then we've got things like, well, share X. So that essentially comes into play if you have multiple rows of subplots. Do we want them to share the X-axis? Do we want them to share the Y-axis? And then there's a lot of things like height ratios, width ratios, and these are really talking about cases where you have more than one subplot. So I'm not really seeing anything, right now, obviously, that is giving me any insight into how I can resize this, figure area. But notice right here at the very end, you've got figure keywords, right? And this is kind of one of those cases where, again, it might get a little bit confusing, because what's actually going on is when you call plt.subplots, matplotlib is calling, some additional things, some additional arguments, and then it's actually passing some and utilizing some code from maybe another method that's built into matplotlib. So if you provide certain arguments that are maybe used for that other method, like in this case, there's a method going on that will generate that figure, and it's just passing those through. But you don't see them. You just see figure keywords here. Well, how do I know what those arguments are? Well, typically, and matplotlib does a very good job of this. If I look at these figure keywords, then I go down. Right. So, well, what are these figure keywords? It says, well, any additional keyword arguments are passed to pyplot.figure. All right, so this is saying, okay, well, it's passing any additional keyword arguments to .pyplot.figure. Now remember, we imported matplotlib.pyplot. So what it's doing is it's essentially passing them to matplotlib.pyplot. So it's just kind of, maybe skipping that matplotlib part. It's assuming where you're using the library, so you know what kind of the core namespace is. And then it's passing these to .pyplot.figure. So what I'm going to do is I'm just going to do pyplot.figure, and I just put that right into Google, right? So I just did a search, and then, okay, so we see right here, matplotlib.pyplot.figure. It was returning the documentation for matplotlib 3.9.0. Let's just take a look at that. I'm not sure exactly what version I'm on, but this has been very, very stable for a long time, so it's probably going to be okay. All right, so you notice that it says, hey, well, if you give me any additional keywords, so when we're looking here, it says all additional keyword arguments are passed to this call. So apparently subplots is calling .pyplot.figure at some point to generate that figure, most likely. So we can look and see what arguments it takes, right? So it takes a num, so you can give it a unique identifier. So that's what that is. But more importantly for us, it takes a fig size parameter, which is expected to be a tuple of floating point numbers, where the first is going to be the width and the second is going to correspond to the height in inches. All right, so even though we don't see fig size as an argument that we can pass to subplots, well, we know that this figure keyword, whatever other keyword arguments we pass in, are just being handed off to this pyplot.figure function, and it has a keyword argument called fig size. So we should be able to define in subplots and just say fig size, and let's do something like 5 by 3, so 5 inches by 3 inches, where the first is the width, and we're going to make that call. All right, and now we've got that image resized. And if I were to change that to 10, and it makes it really, really wide. So we can see that that is in fact working. So that's one thing that you kind of need to note within matplotlib. And this is not just a matplotlib thing. There's other libraries that of course will do this. It's just matplotlib I see do this more often, and maybe Seaborn as well. So right now we're able to resize our figure, right? So we give it the width in inches, we can give it the height in inches, and this is just passing through to a call to plt.figure. All right, so let's look at a few other things. So we said that we might want some labels for our horizontal and our vertical axes. All right, well, we've defined this AX object, and since I've already ran this cell once, AX is going to be defined in my memory. Okay, first off, what is the type of AX? This will be handy in the future. All right, so this is a matplotlib axis. All right, or an axes object. All right, so if I've got AX and then we hit a tab, again, there's going to be a tremendous amount of things that we can do on this. So this is, again, this library gets a little bit overwhelming because there is so much you can do. Again, kind of my approach to working with matplotlib is I've kind of committed to memory and really learned a set of transformations, a set of methods and things, and I tend to do very, very frequently. And you know, once you kind of build up that mental repertoire of these are the things that I tend to do a lot, it kind of makes working with this a lot easier. So there's a lot of things that I don't use, not to say that they're not helpful. It's just I've kind of built up this internal vocabulary of things that, again, really fit the use cases that I'm going after a lot. One thing that I do want to notice, you'll notice that they have a lot of methods that start with get, and then they have some equivalent methods that start with set, right? So a lot of times if you wanted to say get the current, you know, labels or tick marks or something like that, you would be looking for a get method. Whereas if you wanted to set those values, you would be looking for a set method. All right, so in this case, we're wanting to set the horizontal and vertical axes. And matplotlib, if we're dealing with two-dimensional subplots right here, of course you can do three-dimensional. I would, you know, highly encourage against it. Most of the time 3D visualizations, I mean, if you're truly trying to represent it with three different coordinates, it's going to be just a lot of times really challenging to make it where that visualization is very concise and clear. If you do want to kind of show, you know, okay, a three-dimensional or how things are varying over three-dimensional, I would recommend maybe doing a two-dimensional plot and using like contours in that two-dimensional space. And to do that, or either like a heat map, and we'll see that when we get to Seaborn. All right, but again, we're trying to set horizontal and vertical axes or axis labels. All right, so what we want to do is we want to set, so we're wanting to change something, and in these two-dimensional visualizations, matplotlib is just going to refer to the horizontal as the x-axis, and then the vertical, essentially coordinate system or axis as the y. So if we wanted to set the horizontal axis label, we want to set the x label. All right. So you can give it the X label, you can give it a dictionary specifying things for the fonts, you can give it a label pad argument, you can give it a lot of different things. And again, notice pretty much always at the end of these methods, we've got these keyword arguments or fig keywords. And in this case, it's saying, hey, well, I'm going to pass these off to matplotlib.text.text. So again, if we didn't know what those arguments possibly were, we could just go look right here and pull that up. And let me do that. I just copied that in, so matplotlib.text.text, well, here's the additional arguments that we could pass to that. And we'll see that very shortly. All right, so let's just say for on our X label, well, we called that series X here, so let's just set that label to be X. All right, so now we've got our label right here, right, on that horizontal axis. And then if we wanted to set the Y, we call that Y, so we will just set it to be equal to Y. All right, now let's say that we definitely have it labels now, right? So we have our X label that's shown on, or that label X that's shown on that horizontal axis, and then we've got Y. The one thing about that Y value there is, if you notice, they've rotated it, right? So it's kind of rotated so that it would read from essentially bottom to top. Well, in this case, we're just saying Y. So what if we want to rotate that where it can be read from left to right? So can we do that? So let's look again at our doc string. Well, I don't see anything that would maybe be, what's this loc? Well, this is just bottom, center, or top. So that's not really telling me rotation. Well, what about these keyword arguments right there? So again, they went to matplotlib.text.text. We had pulled that up right here. All right, so what are some of those keyword arguments that we can pass? Well, notice we've got a rotation. Okay, so apparently if we can pass a rotation argument, and let's see what it will do. Let's see if it tells us. I think there it is, so rotation. So if I were to click that, it goes way down. It says set the rotation of the text, so you can provide a float, or you can say vertical or horizontal. So if you give it a float, it's going to specify a rotation angle in degrees in a mathematically positive direction. So horizontal is 0, vertical is 90. All right, so let's try to do that. So let's say rotation, and let's say equals 0. All right, so that works. So if you notice that Y label right now is going to be rotated, we could read it from left to right. But it seems to be, to me personally, it's a little bit too close to the values that are shown on the various ticks on that vertical axis. So what I might want to do is add some padding to move that label a little bit further away from those tick labels. All right. Well, now let's go back into our doc string, and we do have a label pad. And what this is, so label pad, it can be a float, and it's the spacing in points from the axis bounding box, including the ticks and the tick labels. Okay, so a little bit, interesting. So the axis bounding box, including ticks and tick labels, so spacing in points. So let's give it a shot. Let's see what this does. So it says label pad. All right, so I'm going to say label pad, and it said spacing in points. So let's do something. I don't really know how big a point is, so let's just put in something like 50. And we can see that now in this new figure, it's moved that vertical axis label quite a far distance away from that axis. So definitely that seems to have caused the behavior that we wanted. It might just be a little bit too much, right? So maybe we want to bring that back down to something like 20. And yeah, that looks pretty good. All right. So we've done resizing. We've, added some labels to the vertical horizontal axis. And we had to do some rotation and padding on that vertical axis label. Let's also, at this point, let's go ahead and add a title. So I'm going to do this just for this subplot. So I'm going to be working off that axis because right now this axis is corresponding to that single subplot. We'll see the differentiation between that in a later video when we look at, essentially cases where we might have multiple subplots. But right now we're working off this one subplot, and we've got a set method that is set title. Okay. So I can say, well, this is going to be, y versus x, something like that. And then we can let that run. So now we've got this title. What if we want to make some modifications to that? Again, this looks very, very similar to what we saw when we were setting the label. We've got, this location. Instead of a label pad, we've got a pad right here. And then we've got keyword arguments or kwargs that get passed off to, let's see, does it tell us where our keyword arguments are going? In this case, yeah, so keyword arguments are being passed to .text. So again, if we looked at .text, what do we have available? Got to go way back up to the top. We've got all of these things. One of the things that might be fairly helpful, let's see, we've got keyword arguments. Notice this one's actually passing off additional keyword arguments. So let's just look here. These are, it actually tells us in the documentation that some valid keyword arguments are, and I believe there should be a font size. So you can actually pass a font size argument. So if we want to make that title a little bit bigger, we could say font size equals, I don't know what it is by default, let's say 20. There we go. So we made that a little bit bigger. All right, so this thing is starting to shape up. Let's bring that back just a little bit. Let's bring it down to 14. Okay, live with that. All right, so at this point, we've got our axis labels, we've got a title. And one thing I said is that, I don't love, this right and top lines that are bordering that plot region. To me, they're just additional clutter, right? So again, I tend to prefer removing those. And the way that we need to do this is in a matplotlib axis object. So this region right here, the way to think about it is this subplot region. That's your axis. And what we can do, if I do AX dot, it's got a thing called spines. Now it's really kind of odd, right? So if I do AX dot spines, it gives me back this AI matplotlib dot spines object. If I try to see what are some of the attributes, it looks like it's almost like a dictionary. And it is, I guess, in kind of the core implementation. I guess they're using a dictionary to kind of implement this. Let's look at the keys. Again, it's just giving me this keys view, so it's not really being horribly helpful. So again, this is kind of some of the troubleshooting things of like trying to figure out how I can see what we're dealing with in matplotlib. Now let's just look at the documentation. So I'm going to grab this matplotlib.spines.spines. We'll just see what the documentation says. All right, so apparently, you can grab a single spine here. And yeah, apparently you've got a lot of different keywords, so you can have a lot of control over those various spines in there, but still doesn't really give me a tremendous amount of information. That's why, again, this is some of the challenges that I see with people working with matplotlib is, again, the documentation. You kind of have to know how to follow these breadcrumbs through it. But again, you kind of learn what works for you. You kind of commit that to memory, and then once you do that, you don't have to look at the documentation very much. So remember, we had this ax.spines.keys call. Okay, I'm going to wrap that in a list just to see if that will actually generate those keys as a list. Yes. All right, so here's the key. You've got left, right, bottom, and top spines. So the left is over essentially where that Y, that vertical axis label, and the right is going to be on the opposite side. The top border is going to be that top spine, and then you've got the bottom. All right, and the way that you can control whether they're visible is you can say, well, give me ax.spines, and then you can essentially, it's almost like indexing them. So I'm going to notice right here, I've got double braces on the left. So you're opening that with essentially a brace, and then I'm going to provide a list of spines. So I want the right one, and then that top one as strings. and you can call set visible. All right, and set that to false, and that's going to remove them. All right, so to me that looks a lot more clean, right? So if we only wanted to remove the top one, we could just remove that right here, right, and we still will end up with that one on the right. Excuse me. What if we wanted to remove all of them? Right, let's just see what that looks like, right? So we would have our left, our right, our top, and our bottom. All right, so that removes them all, right? So we've got, pretty good fine-grained control over which of those that we want to remove. So at this point, I'm just going to remove my right and my top. Very good. Awesome. Okay, so what we're going to do now is the last thing I want to show you is sometimes we might want to draw an additional line on here. So let's say that we want to draw a line at the minimum, right? And we know the minimum here is going to be 0. So we can draw just horizontal or vertical lines using some additional calls. And I'm going to show you both. So if we wanted to draw a vertical line, so a line going from bottom to top, what we need to use is there is a method called axvline. All right, you give it the x value, and optionally you can give it minimum and maximum for y. And that x is going to be a float in data coordinates of the vertical line. So if I want to draw a vertical line showing where the minimum occurs, so I want that to occur at 0, I can say we'll put that at 0. Okay, so we've got our line right here that's showing us that essentially the point on that horizontal axis where that minimal value occurs. Now, one thing you might say is, well, gosh, it drew it blue. It's the same color as our data. Can we change that? Well, of course we can. We can pretty much change anything with matplotlib if we can figure out how to do it. So again, Shift Tab. Here we go. We don't see anything that's seems like it's related to the color, so I'm going to look into quargs or that keyword arguments. Well, that's going to line 2D. So I'm going to have to give Google just a little bit more help. So I'm going to say line 2D matplotlib. All right, so here we go. We've got a line 2D. Here's some things that we can set. So we can set the line width, the line style, and maybe the color. All right, so let's actually grab those 3. So I'm going to grab line width, line style, and line color. All right, so I'm going to just put those in there as keyword arguments. And for now, let's just leave line width and line style equal to none. And let's set color equal to K. Or I think you can just write out if you want to be explicit, if you don't, because some of the colors in Python are referenced just a little bit different. So I think I can just do a color is equal to black, or color is equal to K is also indicating black. If I wanted to make my line style a little bit thicker, right, I can maybe say we'll set that equal to 5. Right, so now it's a thicker line. And my line style, let's see if they give me some information here on line style. Yeah, if you look, right, so there's some different ways. So like you can do this dash dash. So let's do that. There we go. All right, so maybe that's what we want. I'm actually going to bring that line width down a little bit. It's a little bit too much. There we go. Let's give it just a little bit more thickness. I get very picky with plotting. All right, so maybe that's good. And then maybe we want to also put another line that's showing the value of that minimum along that vertical axis. So we want a horizontal line at the point of the minimum, which is going to be 0 as well, because 0 squared is going to be 0. So as you might guess, we can do an AX instead of a V line. So V gave us a vertical line. We can do an AX dot, or not dot, but an AXH line. And I'm going to set that to be 0 as well. All right, so again, we've got our same problem. So let's just copy those things down. There we go. So now we know, okay, both on the vertical and horizontal axis, where does that minimum occur? All right, the last thing that I'm going to show you, because again, these are kind of some core things that I tend to do a lot. This is not all of the things, right? But this is a good bit of them. I'm usually wanting to modify labels, maybe add a title, do some indications on the plot, handle those spines. But another thing that I do quite often is I want to save these things, right? Because maybe I want to put these in a report. Maybe I'm writing a paper and I need to add one of these figures to it. So it doesn't do me a whole lot of good that this thing is rendered in Jupyter. I don't want to bring up a screenshot tool and take that screenshot and save it, because it's probably going to be, poor resolution, poor quality image. So I'd like to be able to save it. So I'm just going to go over to my folder right now. So notice I don't have any images in that folder. All right. So what we can do, and this is going to be called essentially at the overall figure level. So this is, a little bit different. We'll get more used to this as we see a little bit more variation. Right now, we're just doing a figure with one subplot in it. So it's kind of really hard to see the differentiation at this point. But just one thing to note, so if we want to save this, instead of using AX, which we've done a lot of our calls on that axis up to this point, we want to do this with PLT. So I'm going to do a PLT, and the call is save fig. All right, let's look at the doc string. So this one's, the signature is very non-informative. So it says it takes arguments and quarks, right? So arguments and keyword arguments. But if you look at the call signature, it does give you a little bit more information, right? So again, it does have some keyword arguments, but this is what it's taking. So when you call savefig, you can provide a file name that is expected to be the first argument. And then you can give it a lot of other things, right? So interestingly, so if we look at this file name argument, all right, if you can provide a format, let's see, so a format right here. All right, so if you set that format, it determines that. But if you do not set format, then the format is inferred from the extension of whatever name you give it. Well, what does that mean? Well, let's say that we wanted to call this matplot, right? And we wanted to save this as a PNG file. Well, we would do .png. Let's see, I've got to close my file name. All right, now if I look over here, taking it just a second, notice that I've got a myplot.png file. All right, so there's our figure. All right, if I were to actually go to my computer and then go, there it is. So if I look at the properties, this is a PNG image. Okay, so now we can use this wherever we need to. So that is our PNG image. Notice it kind of cut our Y label off. Right, so it cut off Y, it cut off X, and then notice it's got some space on that right-hand side. So it cut off our labels, and it's got some space on that right-hand side. So that's clearly not ideal, but it did save a PNG file. All right, what if I change this to a JPG? So maybe for a JPEG. All right, so that runs. Now when I look here, I've got a JPEG file. Again, it kind of cut things off, but this is actually a JPEG image file. All right, what if I want to say this is a PDF? Right, it will do that. So it's learning, if you're not providing an explicit format, it's figuring that out from the extension that you provide. So here's our PDF version. Now, if we look at this one, because this one's nice and large, if we look that Y label, so our vertical axis label of Y that we had added and that horizontal axis label of X, they got cut off. Right, so that's of course not ideal. Let me delete those images real quick and just show you. So one thing that pretty much every time I call plt.savefig, what you want to do, one of the arguments is this bbox inches. All right, so let's look at what this does. So it's the bounding box inches, so only the given portion of the figure is saved. If tight, it tries to figure out a tight bounding box of the figure. So if you remember, when we did PLT subplots, well, it generated a figure, okay? And we put objects on that figure, and then we actually added some labels to it. Right, so when we said, oh, set the X label and set the Y label, but the figure was generated first. So when that figure was generated, it was generated with a bounding box, and then we added stuff to it. But that figure, those bounding boxes for that figure, or that bounding box for that figure, is not getting updated. So that's why we're kind of clipping those labels, because we did something to the figure after the bounding box was generated. So what you can do when you do bbox inches, you're telling matplotlib, hey, go back and look and try to figure out the best bounding box for this. And pretty much this is what I use all the time. You can specify pretty much, again, every time I call savefig, I'm going to put this option bbox inches. So bounding box inches equals tight. Let's run that again as a PDF. It doesn't change in how it's being rendered in Jupyter. But now when we go back and look at our plot that was generated, right, it's done a much better job, right? So our labels that we added are there, they're visible. And then if we look along that right-hand side, there's not as much white space, right? So it's done a pretty good job of going in there and saying, hey, you know, we had this bounding box of this figure, but they made some changes. So let's look now and figure out what's going to be the best layout. And again, you can look as I zoom in, right, with this PDF representation, very, very high resolution. So a lot of times if I'm generating images, if you're able to put things in as a PDF, you can get really, really surprisingly good resolution as you're writing them out as a PDF. Let's look at a PNG. All right, so now I'm going to go to this PNG file. We'll bring that up and I'll try to start zooming in. Let's see, will it allow me to up here? So let's bring that into 200. And you can see there's a little bit of fuzziness, right? So not as good resolution with that PNG. Right? A little bit of pixelation as I do that zooming. Right? So PDF tends to be by default a very, very high resolution. If you do it as a PNG, you'll get some pixelation. You can make that image larger. So one way that we could combat that is because, you know, we generated this PNG and it's apparently coming out 475 by 317 pixels. Well, we can generate that larger. Or when we go into that save fig, remember it had this DPI and by default that's set to the figure. Okay, so it's using the figures DPI, so dots per inch. Let's just see if we can manually change this. So DPI, let's say, I don't know, this is probably, let's just say 2000. I don't know. It might balk at that. All right, it didn't. All right, so now let's try to zoom that thing in just a little bit. Yeah, so you can see if I were to zoom in to maybe 200, let's kind of, there we go. All right, so we got a lot better resolution. So it's still, if we get real close, things kind of fuzz up a little bit, but much better resolution on this. So all of these things you have some control over. All right, so hopefully that gave you an idea of some basic customization that you can do on your matplotlib figures. Change that back to PDF. I just tend to like that. All right, so this tends to be my go-to. There are certain cases where I'll definitely do a PNG. But this is, you know, we did a basic line plot with dot plot. We've looked through, a lot of times I'm wanting to adjust labels, the title, maybe changing some spines depending on the thing that I'm plotting, maybe do some horizontal lining, changing the figure, of course, the figure size, and then saving the figure. All right, so that is some basic setup for a matplotlib figure and configuration of a particular subplot axis.